This is the second video on section P4 on factoring. Remember yesterday the first factoring technique that we talked about was taking out a greatest common factor, or a GCF. So every time you approach a polynomial and you're trying to put it in factored form, always remember that you want to do that. So that's what we're seeing in the first one. We do have a common factor in this polynomial because they each have a variable of y in there, so we're going to be able to take that y out, and that will leave us with a y to the fourth, and a y to the second, and a minus 20. Now this polynomial is in a little bit different form than what we're used to seeing in terms of the trinomials we were doing yesterday. We've got degrees of the y's that are different than what we're used to seeing. We've got a fourth power and we've got a second power. But the relationship of these variables, these powers to each other, is what we mean by having a trinomial in quadratic form. So our typical trinomial is ax to the second power plus bx to the first power plus c. When you're comparing those powers of those variables, the highest degree is double the first degree. So when we have that, then we typically come back and we've got our factoring where it's going to break down in terms of power of x to the first times x to the first. So we take that idea and transform it over here, in that we certainly have to keep our GCF factor we took out, but as we go back and we try to break down that trinomial into two other trinomials, we're looking at the degree here, and the powers of y that we're using down here are simply going to have to multiply by each other to give us back that y to the fourth. So that's going to give us a y squared times a y squared. Right? And then we can continue on as we normally do with other polynomials. We're looking at the factor of the last term to come in here, so that they multiply to give us negative 20, but so that they add up to give us a positive 1y. The signs that we're looking at in the last term is negative. So that would also mean that our signs have to be opposite, positive and negative. And then the correct factors of 20 that are going to apply here are a positive 5 and a negative 4. So the factoring that we've done is back in the sense of just the typical trinomial in terms of ax squared plus bx plus c. Now, we also have to make sure that we've finished the factoring completely. We've already taken out the greatest common factor in the y, but the polynomials that remain might still also have factors. And in this case, we do have another step to do here because the last polynomial is a difference of squares. So we finish up with the last factoring step. We've got y, the y squared plus 5 does not break down, and we've got a difference of squares in the last two. And now we have all the factors that we can from that polynomial, and it's in what we call a factored completely form. Now we move on to the second example for this video, and we're going to talk about factor by grouping, which you've done yesterday if you were factoring your trinomials with the split the middle term method. Factor by grouping is going to do precisely what it says. We look at the entire polynomial and we see some common factors, but we don't see them in the entire polynomial. We only see them within little groups. So what we do is we break up and take those little groups, put them together, and we take out the GCF that we can from those groups. In the first grouping, we're going to be able to take a common factor out of 3x, and that will leave us a factor of a minus 4b. In the second grouping, we've got a common factor of 2, but we've got that negative sign in front of the 2a. So that means as we're taking our GCF out, we are taking out a minus 2. And as we write our remainder in the parentheses, we've got a factor of a left, and dividing the negative from the plus 8, that's going to have a minus 4b left there. Now, you're not finished because you've still got this little minus sign in between. This is not considered a product with that subtraction sign in between there, but we do have a common factor in that binomial expression. So that common factor comes out, the a minus 4b, and once it comes out, the remaining factor is 3x minus 2. And as we talked about yesterday, your parentheses are next to each other, and that indicates that you have a product, and therefore your polynomial is finished and factored. Now we're on to the last part, which we've kind of talked about already. It talks about factoring completely, so that means you have to look for multiple ways to make sure the polynomial is got no more factoring left in it that you can do. And the key here is, as we're indicating with the hint, is always look for a GCF first. So our third example has a GCF. We check out the terms. The coefficients are all even, so we're going to be able to divide a 2 from each, and they also have a power of b to the first power. So we write down that GCF, and the quotient that remains as we divide that out from each term, that will leave us with 36 x squared and a 12 xy, and then finally we'll have a positive y squared left there. So we've got a combination of variables here. We have to bring the GCF down that we took out, and we have a trinomial that's left. There's no common factors left, so we're going to be looking for the two binomial factors that will multiply that. And even though there's a combinations of x's and y's, we're still going to be looking at this with the intention of the first term having to have its factors here and here to multiply itself, and the last term, the y squared, to have its factors in here. So my signs as well are important. This is what we're doing with the other trinomial factoring. Both signs are positive, so I'll have two positives. The y squared can only break down one way, so as I put my values in there, that's going to have a product of y times y. And coming back here to the 36, I need factors of 36 that add up to 12. And that would make a 6x and a 6x. Right? Now looking back, we can also recheck those, the first term and the last term, and they were perfect squares. So again, we could have approached this with the idea that it's a perfect square trinomial, trying in the square roots for the first term times the first term, and also the square roots for the last term in terms of the y times y. And sure enough, the products of the inside product and the outside product do combine to the 12xy. So this was a perfect square trinomial. Finally, we can write the answer, if we'd like, just putting that binomial factor in once and squaring it. Alright, on to the last one. It says there's two possible answers here. Either way we do this, we're still going to approach this the first way, and that is, as we said at the beginning, that you've got to look for that GCF factor. If you don't look for that here, you're not going to have a chance at doing it at all. So the factor that we're going to be able to take out is a 2, and that will leave us with x to the 6th minus 1. Alright, now there's two terms, so we've got to consider the possibilities of factoring a polynomial with just two terms. In this case, because the degree of the x is even and the constant at the end is a perfect square, as well as having a difference of squares, we can approach this as a difference of two squares. So I'll be able to keep that GCF factor and write my two factors, and what I need in the first spot here is going to be the square root of the x to the 6th, and that would be x to the 3rd. So I will have x to the 3rd times x to the 3rd, need that plus minus pattern, and then I need the square root of my second term, which is just 1 and 1. I'm going to separate this a little bit so that we can keep the two problems separate, because we're not finished yet with this guy. Each of the two binomial factors that we have are a sum and a difference of cubes. So we need to go back to yesterday's lesson and use the factoring pattern for that sum and the difference of cubes. So, taking the first one, we're going to get the binomial factor first. This is x to the third. Its cube root is x. The plus 1, we're going to have a plus sign in the binomial factor, and the cube root of 1 is 1. The trinomial factor that follows from there, we will square that first term. We have to change that middle sign. Do the product of the two cube roots that we had there. So that's going to give us a minus 1x, and then finally we're going to cube that last term. There's a plus 1. Right. As I write the factor for the difference of cubes, same type of pattern here. I'm going to keep that down below. This time your binomial factor is going to be an x minus 1, cube root of x to the third, and cube root of 1. And then your trinomial factor follows there, squaring that first cube root, changing the sign again, so it's a plus 1x this time, and then a plus 1. So again, reviewing here, we are taking the square of the first cube root, and then we're changing the sign in the middle, and we're doing a product of those two cube roots in here, and then finally squaring the last one. And if you'd like to rearrange your answers, making everything nice and neat and tidy, you can put it in an orderly form. You can put your binomial factors together, and then you can put your trinomial factors together. Something the book probably does if you're looking in the back and going to check your answers at the end, as we keep telling you to do. Okay, so that'll take care of case 1. Now, let's try it again with a second method and see what else we can do with this. All right, and rewrite the problem. 2x to the 6th minus 2. And we'll take that 2 out again, leaving the x to the 6th minus 1. Now this time we're going to reconsider the problem. There's two terms. There's a difference. But let's consider this now, that this might be, instead of being a difference of squares, because the power is even, it could be a difference of cubes. So I'm going to rewrite this as though it were. I'm going to write this as x squared cubed minus 1 cubed. So that I do have two terms and a difference of perfect cubes. Now, this is actually going to be the shorter of the two methods. So as I come back and I write my expression, there's my GCF of 2. Now for the difference of cubes, I'm taking out the binomial factor, the x squared minus 1. And now I have to use that pattern for the trinomials. I have to come back and I have to square that first term. That's going to be x to the 4th. Then I have to change the sign of what I started with the binomial factor. That's going to change to a plus 1. And I am going to take the product of those two cube roots that I had there. So it's going to be a 1x squared. And then finally, I square the last term. And there's a plus 1. All right, almost finished. Not quite as much work as the first one, but you do still have a difference of 2 squares in there. So we can finish it up. 2 times x minus 1 times x plus 1. And the trinomial that we were left with did not factor. We can leave that as x to the 4th plus x squared plus 1. And there you've got the second combination possibility of factoring your 2x to the 6th minus 1. All right, that's it for factoring. We had 2 days of notes on it. You've taken care of all the different factoring techniques that we could do. Tomorrow in class, you're going to be working on day 6 homework. And we will see you then. Have a good night.